Kaggle supports builders all over the world.
Being part of Kaggle, we really believe in the power of a community to drive frontier progress in AI.
Technology is not just what you do, but how people feel about it.
Hey, I'm Meg Risdal. I lead product for Kaggle, and I'm really excited to be joined here today by Sara. Sara is CEO and co-founder of Adaption Labs. She's part of Kaggle's research advisory board and former VP of research at Cohere. And I'm really excited to have this conversation with you, Sara, today, because we've known each other for so long, 9 years, and something that I've always admired about you is how you've been such a strong vocal representation of how to go against the grain in AI and machine learning and how important that is for driving progress in AI. And so to start, I'd really love to go back 9 years ago when we did first meet. Would love to hear sort of where you were at in your career at Google at that time, what you were working on, and how that led to, honestly, our paths kind of crossing ever since.
Yeah, it's lovely to be here. I feel so special. And I love how you describe me as maybe a rogue researcher, kind of bending the grain. I mean, okay, so when we met, it was 2017. At the time as well, it was the beginning of a very interesting era where Google and other labs had started this bet of let's bring researchers after the beginning of deep neural networks in 2012, let's concentrate and give researchers the resources to just imagine this new world. And so it was this crazy bubble up time of ideas. DeepMind was really one of those places where there wasn't any other spot like that in the world. And I remember you had just joined, Kaggle had just joined Google.
That's right, yeah.
Which was another pivotal moment. In some ways you look back and so many breakthroughs came out of that group of people that were there at that time, which when you think about what leads to breakthroughs, it's always a combination of like the ecosystem you're in, the people you're with, and just the permission to dream, which is really interesting to think about.
And it feels like we're in that moment again today. There's a lot of dreaming that's going on, but there's also a lot of bets being placed on just pure scale. One of the things I'm excited to talk about is, what are the bets outside of just pure scale and pure compute, because I think that's sort of like what your background and your history has brought to the shape of the field. In all of this time spanning your career, you started doing a PhD at Mila. You spent time at Brain, at DeepMind, and at Cohere. Now you've started Adaption Labs. What was the through line across your entire career up until this point?
I think I'm very problem-driven. So most big leaps have been around a problem. I think there's different types of researchers. So there's certain researchers who are like, oh, I only do image, or I'm an NLP researcher. And that was never what moved me. I think, early in my career, I did both computer vision, and then I did a lot of work on NLP and then multimodal. And it wasn't as important, the domain. It was like, what question am I trying to answer? And for a lot of my career, it's been around, well, if I make progress on this question, will it translate to real world impact? So a lot of my early research was around efficiency. How do we build much more efficient models? And then I did my PhD with both Hugo Larochelle, Aaron Corville, incredible people. But then I was at Brain and DeepMind for a long time. And then I started Cohere Labs. So I joined Cohere to lead their whole research arm. And there the goal was, okay, still very interested in efficiency across all these modalities, but multilingual expansion was really interesting at the time because it both requires efficiency. It's actually one of those core questions of machine learning, because what is extremely difficult for our current models is to learn with little data and to actually work for many different parts of the world. Like, humans are very robust. We can go new places and learn things. Our models are very brittle. And so multilingual represented all those problems, but it was also one of those things where if we made progress on it, we would really see translation to like real world impact. And when we started on this, the field was pretty dismal. We had some efforts like Bloom. I don't know if you remember.
Yeah.
Like that was when we started working on this, and Bloom had been great. It was an open science effort to improve coverage, but none of the major models even reported languages. No one cared. And Bloom was it wasn't really the same frontier AI that other things did. So that's when we started at Cohere Labs, and we're like, let's do this. And adaption has been similar. It's been so problem driven. I think it's about, hey, we're clearly moving from this era where you just build a model and throw it over the fence and hope for the best to an era of interaction where the model has to interact with the world. And that forces you to care about different things. And so I always think, like, where am I most likely to be successful at working at this problem on the edge?
I love that. One of the things that really sticks out to me when I look at your career is the work that you did on the Aya project as part of Cohere Labs. Of course, being part of Kaggle, we really believe in the power of a community to drive frontier progress in AI. I'm curious, like, what is your perspective on working with a globally engaged community on a project like Aya? You worked with over 3,000 contributors from all over the globe. What did that mean to you?
Yeah, so I mean, if you think about it, when we started Aya and that multilingual project, it was pretty ambitious. We wanted to double the number of languages covered by any model to date. And we wanted to do it in a way that actually served people all over the world. But it was so formidable because if you think about it, the internet was basically all your high resource languages and then translated garbage versions of the other languages. And at the time as well, like, we knew it was pretty critical that if we were going to do this in any way, it had to be really efficient. And so it was, I would say, one of the most powerful projects because it involved so many researchers. What I would say is interesting, and I think Kaggle is super interesting in this respect as well. So most research projects, you produce the idea and then you kind of move on. There's very few research projects that also builds an ecosystem. And when you combine the two, it's almost one of the most things I'm most proud of because the whole ecosystem continued. And I think Kaggle in the same way, it brings together these people, but they're also at interesting junctures in all of their lives where for them, it also compounds like a feeling of like, now we can do other things together. And that was really profound about Aya because it started a whole initiative, which was really interesting. And it really compounded like all the efforts there. So we ended up doubling the amount of languages, but also the amount of subsequent acceleration for those languages and just how it set the tone and the whole ecosystem was pretty powerful.
Yeah, that's amazing. I'm curious, beyond, the success in terms of, the languages that you're able to cover through Aya, what were other ways that you looked at success or saw success through the Aya project?
Oh my God, so many PhD students came out of Aya. like it was pretty absurd. I mean, it was really incredible because we had so many people go straight into PhD programs. And you have to think about it. Computer science has all this current resource and visibility. And so who PhD spots go to is actually really important, and what parts of the world. The other thing is just the unexpected uses of it. So much of like our work with Telugu, for example, or very rare languages were people preserving like ancient scripts. And that was super cool to see because it was so profound. And it was people's grandmothers who wanted to contribute. And so the dynamics, I always say technology is not just what you do, but how people feel about it. Like your work as a researcher, you can create a breakthrough, but unless people feel like it's meaningful to them, it's a breakthrough in isolation, or at least it's not the type of work that I want to do. And I think I was very emotional for many people. So that was also super special.
Yeah, that's incredible. I mean, I studied linguistics, I studied sociolinguistics, so I could definitely appreciate the impact that the project has had. It was very, very cool to see. So now I want to talk about your 2020 paper, The Hardware Lottery. In this paper, you argued that the success or failure of an AI project depends on hardware, not the inherent merit of the idea. Tell me more about what that means to you.
I basically is saying, and that paper, I think, was really an attempt to grapple with, well, what is computer science history today? And it's basically saying, well, if you look at it, pretty much every breakthrough in computer science history since the 1950s, when we have modern computer science history until now, all the major breakthroughs, but also all the delayed successes have been dictated not by what we as researchers like to think. We're so precious about ideas. We like to think we're the masters of like what gets to succeed and what doesn't fail. In fact, it shows that we've had very little control. What's determined everything as being the hardware lottery. So whether your idea works with the hardware or doesn't determines does it succeed or fail. And one of the most notorious examples of this is, to be honest, deep neural networks. Like if you think about it, all the components for deep neural networks, backpropagation, which, a cheeky fact, it was actually invented 3 times independently.
That's right.
By 3 different researchers, but that was all done by 1988. And then Jan LeCun, of course, like he came in the next year, he spotted the last invention of backpropagation in 1988. He said, let me combine this with convolutional neural networks in 1989. The gap between that and then finally having a breakthrough in 2012, that delay of almost 20 years of like stagnation and waiting for like the right solution is the hardware lottery. And that's pretty wild when you think about it, because during that time, we also favored ideas which weren't ultimately successful or scalable. And so it means we have to care about hardware.
Yeah, that makes a lot of sense. And it's something that we think a lot about at Kaggle, because we do try to provide open, no-cost access to at least a level playing field of hardware for our community to build and ideate, innovate, etc. But
that was like one of the most profound releases Kaggle did, by the way, like backing up the collab so users have access, because people don't realize it because it sounds trivial when we talk about mega data centers, but that probably unlocked a lot more innovation than any single data center did. So I don't know, I think stuff like that is very special.
So it's now been 5-6 years later. What has changed since you wrote the hardware lottery paper?
I think what's interesting is most people read that paper, and what resonated with them was that, oh, this happened. You know, deep neural networks were delayed. This is a big deal. But I don't think people realize that we've only made it worse since. So there's 2 things that have happened. One is that we have designed hardware that, because deep neural networks have been so successful, basically optimized for deep neural networks.
Right.
So if you think about deep neural networks, they're basically 99% matrix multiplies, a single operation. And almost all hardware today is designed to make that go very fast. What's crazy is it makes it hard to stray off the beaten path of ideas. Anything that requires too much transfer between CPUs and GPUs, any type of squashing operation, adaptive compute, these are all ideas which work really poorly with our current hardware. But they're also really the future. Like if you think about the idea that you want to spend differing amounts of compute on different problems, which is pretty fundamental to what most people intuitively understand, you're probably going to want to have a lot of innovation in the systems. I actually think we're at a reckoning point, because all agentic workflows, anything that requires like sequential processing, basically doesn't play well with this idea of everything in, everything out. And so it's already causing a reckoning of like, what is the next system that really supports these much more fluid, branching types of jobs that actually are probably the future of how models interact much more fluidly with the world.
Now I want to talk about a more recent paper that you and your collaborators put out last year, the leaderboard illusion. Tell us more about the leaderboard illusion.
So the leaderboard illusion was actually, in my eyes, I consider it one of the most important papers that we worked on, because what that paper finds is that there was a switch towards really an open voting arena where everyone would vote, and it was used increasingly whenever a big model was released. It became the stat that you would quote. And it also signified this meta ecosystem push of, because so much capital was involved and because there was so much pressure on companies, it really represents the ecosystem shifting from essentially all of us around a few benchmarks and everything is transparent, to moving to an ecosystem where the pressure to report something that is successful has created odd incentives. And what the leaderboard illusion found was a few things. Like one, it found that really a handful of providers were manipulating using many different private variants to basically get the best shot at the best score. And what was interesting was that this wasn't made aware to all the different models. And so basically a few people had a lot more attempts to win the race than others.
Right.
But we also just saw that you could basically use your previous historical data to just get really good at the arena, because it was a certain distribution, it was a different type of questions. There was a lot of developers. And so it just meant that the stacks were kind of skewed on this leaderboard. What does it mean and why was it important? Because I think it shows two things. One, I think the degree of distortion shows the amount of pressure on these scores and perhaps shows, hey, we're not a research community anymore. There's so much capital and visibility on the AI field that what was positioned as an academic leaderboard, in fact, ended up pretty distorted. The second thing it shows is that even these more open, realistic world challenges, the methodology has to be clear, because otherwise, if some people know there's private testing and other people don't, there's just clear manipulation there. And so I think it speaks again to the idea that there has to be trusted third parties who have the right incentive structure to make progress.
So, given your takeaways from the leaderboard illusion, what do you think a fair leaderboard does look like?
Yeah, and maybe I won't say what it looks like. I'll say what I'm grumpy about.
Yep, that works.
So I think there's a few things. One is you basically can't open source evals anymore, otherwise they get trained on. So many of our evals are kind of static. They take a huge amount of effort, but they don't really represent how most work is now about how a model interacts. So I think there's a fantastic paper that we just released. Sayesh Kapoor was the first author that was about this, hey, we need an era of open world evals. And that's super important because that gets the complexity of how these are going to be used. Like if you think about agents, you need to be able to understand reliability and safety in a much more multifaceted way. Too much of the time that academia has been spent is on these evals that then get hill climbed.
Yeah.
And it has to be a wider picture of like, what is this eval for? And is it easy to immediately manipulate it as soon as it's released? And I think there just has to be a reckoning with that. I'm more interested in like real world evals where like, it's harder to compare, but as long as you have a clear notion of success, you can have unbounded ways of getting there. And I think this is part of a wider effort where our field has to move towards a more messy, but maybe more pertinent idea of like, real world environments. And that's super interesting to think about because it puts us more in the robotics evaluation realm,
Right.
which is messy and has a bunch of problems there too, but at least it might be more a better proxy for what we're trying to get at.
Yeah. Yeah. And this is something that we think a lot about at Kaggle because every competition we launch is essentially a benchmark. It's a leaderboard. What kinds of things do you want Kaggle to be thinking about when we are designing competitions that represent essentially evals that measure frontier and state-of-the-art solutions to these problems?
Well, the beauty of Kaggle is that because there's a prize, there's the accountability of people who really want the prize.
Yes.
And so it means that people are very grumpy if the objective is not well specified. And if it's easy to cheat, other people will call it out too because they'll be really annoyed. Because you also typically have the same people with differing incentives. Some people are doing it as a researcher, other people are doing it because they won the prize, other people are doing it as a hobbyist. And so that accountability is different. And it's very interesting because I think that is what has led to the longevity of those goals being meaningful. Because here's the other thing, like if you want to get people to participate in your competition, you got to make it something interesting that is actually at the edge of what's possible.
Yes, I agree. It is a lot of fun. So on the slow death of scaling, you wrote that smaller models can often outperform much, much larger models on the same task. Yet the industry is still pouring tons of capital into just Manhattan scale data centers and scale in general. Why is this wrong? Because this is something we also see play out in Kaggle competitions.
Yeah, I guess you're asking like maybe more cheekily, who's wrong?
Yes, that's right.
Yeah, I mean, I think it's interesting. So there's two things happening at once. With the slow death of scaling, really what I'm pointing to is that we are at an era actually of really innovation and questioning what's the base amount of progress. When me and you met like close to a decade ago, like that was the beginning of what I would call just, there had been scaling to that point, but it was always in the 100 million parameter range. That was like the ResNet 50 to ResNet 101. Do you remember that era?
Yeah.
but there was an inflection point with transformers, which were much more easy to scale,
Right.
where basically the size of the model dominated everything. And the next decade was basically, let's throw as much compute into the model as possible. But transformers and arguably pre-training, most of the innovation done there now is about the data. But I think most people who think about this agree that the transformer is saturated. And in some ways, that's exciting because our job for the last 10 years was almost like being a hardware designer where you're just trying to stuff transistors. And now I think it's fun again because so much innovation is how do you use this model to interact with the world? And that is a very different set of problems, but it also opens it up where innovation is about the best recipe, not who has the most GPUs or TPUs or compute for pre-training. Here's the thing, is that doesn't change the fact that a lot more people are using this technology. So I think data centers and that trend is really about that. So even if
Right.
you can get away with a smaller model, if so many people are using it, you typically have way more inference workloads where people are using it at test time. Also, the type of compute where we're going to innovate has moved to test time. And so I don't think it's irrational, the data center build, because it's
Course.
really about people using it every day. But I do think what's interesting about the dynamic and people should realize is that the concentration or disproportionate advantage that was in frontier AI labs, I don't think is no longer there just because they can like supersize the size of a model. In fact, I think that's fun to think about because it means we're back in an era of like research and innovation. And that is kind of all bets are off. And I think that's why you see so many kind of contrarian now bets about what is the next era of intelligence going to be, because people realize that we just can't train the biggest model anymore.
Yeah. One of the things I want to ask you is if Kaggle wants to foster innovation on, frontiers of like efficiency and more of this like innovation beyond scaling, what kinds of things would we invest in terms of the competitions that we run, the benchmarks that we host?
I think Kaggle is in this really interesting position because one of the most interesting aspects, even to what we're doing at Adaption, is we're trying to really allow models that basically learn more efficiently on the go. I see this as part of this wider trend where now there are much more powerful techniques to basically suggest and infer or auto learn a problem. Like we
Right.
had the auto ML whole effort in the 2013s, into the 14s, 15s, 16s, and that largely failed at the time because the building blocks were too heavy. Now we have these much more expressive chains where you can like suggest, hey, this is the best way to train this model for this problem. So I think it gives people a lot more agency outside of frontier labs. And it means that the art of research can be a problem that can be learned, and you can deploy agents to like learn the best configurations. And I think that's a very fun place for Kaggle to play because you have so many interesting previous historical experiments of what it looks like to innovate. So I think stuff like that also just empowers people who may not be as technical to feel like they can succeed on a previously unknown problem.
Completely agree. So where do you think we are now? Do you think that this is still a contrarian view inside of Frontier Labs, or are people really coming around to this idea?
I think to some degree it's still contrarian, but I'll say why. I think it's because it takes time and inertia and how organizations are organized. And the truth is, if you've bet on scaling for the last 10 years, your whole scientific structure is basically orchestrated around that. You have a pre-training team, and then you have a continued pre-training team, and then you have a post-training team. And that's all bets around the idea that compute drives everything, and so you need this specialization. Whereas if you believe now that, hey, transformers are saturated, I need to think about interaction with the world. You need a different combination of skills. Like firstly, you care about serving very fast. You think about efficiency of like, how quickly can my model interact and learn more?
Late last year, you launched Adaption Labs on this idea that models should learn continuously. What is the simplest version of what you're building?
For me, this problem was how do we avoid monolithic models? I think people intuitively understand two things. One is that we shouldn't ship the same model to every person. And that the other is that if you do that, you are incredibly inefficient because for difficult and easy problems, you're basically applying the same model. And really, adaptation is about how do we train models to adapt real time and to change as they see new data. And this is pretty important, not just for things like continuous learning, which is really critical right now as we think about long horizon tasks. We want models to be efficient and be able to update as they explore, but it's also just really critical to making technology work all over the world.
So you're thinking about things like free learning and how to change the behavior of the model on the fly without changing the weights. For someone who's only ever fine-tuned a model, what changes about how you approach this?
Yeah, and actually, we're allowed to change the weights. We're just not allowed to do gradient learning. Why do we care about it? Because I think so much of being able to continuously learn, frankly, is determined by the speed at which you can interact with an environment. And whether people feel like it's worthwhile shaping model behavior is determined by, do they see a change immediately? So we also do a lot of training and optimization, but it's all with the view that, hey, the model is going to be way more flexible real time. Most people who have tried fine tuning outside of frontier labs have really failed at it. Frankly, like I think that few people have done it and said, oh, this is so successful, I'm going to use this instead of a frontier model. And I think the reason is typically it takes a long time.
Right.
You have to have your data, and it's really hard to make it work in a meaningful way. And so I think that, if we're providing a meaningful alternative, what people do after fine tuning is to become prompt engineers. And
Right.
that doesn't give them much control, but at least they see something immediately. And that's another reason why real-time adaptation, I think, if you're going to provide more powerful levers, it also has to be super efficient. Because really you want to show people, hey, you can have a lot more control over model behavior, and it will give you a lot more than prompt engineering, but it doesn't take as long. It's much more likely to succeed.
So you've said on prompt engineering that you actually think it should go away and that you've called it prompt acrobatics. Tell us more about your feelings about prompt engineering.
I think it's been really evangelized as like a discipline, or like this is technical and you need to study how to be a good prompt engineer. What's interesting is that different industries have really promoted this as a discipline. Like they've said formal guidebooks to be in prompt engineering. But I think this is just a band-aid for an underlying problem, which is that people don't have much control over AI. And so I actually think our progress on eliminating prompt engineering is actually a symptom of, hey, are we delivering models which actually adapt automatically to how people want them to behave? And this is probably one of the most fundamental problems that is worth working on, because also think about how many people don't have time to become prompt engineers,
Right.
or don't know that you have to insert a certain word to like increase performance by 20%. And I see that as like, hey, let's get rid of this kind of fortune cookie reading, and let's give people much more meaningful tools that actually get them where they want.
So community has been a really strong through line in all of your work, from Cohere Labs, now Adaption Labs. And you actually just launched and wrapped a hackathon with Kaggle, the Uncharted Data Challenge. Why was this the right first community engagement for Adaption Labs? I'd love to hear more about the thinking there.
So the Uncharted Data Challenge was really about, hey, what is the data that doesn't exist yet, or the data that's in the long tail? And adaption at its core is all about, how do we build intelligence that adapts to the long tail? Most models are really good at what's common and really bad at what's uncommon. And the whole reason you care about adaption, continuous learning, is that you really want to adapt to what's not known, and you want to be able to navigate uncertainty. And so the Uncharted Data Challenge was this first pillar of adaptive data. How do we basically make some of this data visible to AI systems? So take something that is really not curated or buried in a folder and transform that into data that can be seen by AI. And for me, that's important because firstly, it really communicates where we're going. We really want to make it easy and scalable for people to, again, have that fully flexible stack. If you have a task, you should be able to adapt data very quickly, adapt the model itself and the interface. But secondly, I really wanted to do with Kaggle, because let's think of our goal and our company is global first from day one. Like that's our intent. And Kaggle supports builders all over the world. It really reflects where we think we're serving and like who we want to build for. And that's pretty important to me personally as well.
Have you seen any of the results?
Honestly, I had no idea how it would go, and it's been insane. So we had an absurd amount of submissions, but it was also the type of data, a lot of healthcare data, agriculture data sets, and the intensity of the competition and the enthusiasm and the emails. And it has been just a massive success as a first competition. So it was available to everyday builders. And what's cool is there's two things that make it very interesting. It's self-serve, so developers can use it, but it's extremely fast. So that a lot of it, my co-founder Sudeep, that's his bread and butter, making infrastructure and systems work. So basically you can adapt your data same day, get it back. What was wild was that I think it unlocked crazy behavior where people would put it through once, refine it, and you get a score before and after. So it goes from like a D to a B.
Right.
Then they put the refined data set back in. So we had the hyper optimization of adaptive data, and I had no clue people would go that far. And I think it's largely because it was very fast. So people felt like they could optimize the optimizer, so to speak.
Right.
So some people, I think the record was 129 data sets. Yeah.
From one person?
One person.
Wow.
Which is absurd. It was so crazy. So I think that's really cool because it speaks to typically when something becomes faster, people try more of it.
Yes.
And it leads to like more interesting strategies because the opportunity cost of getting it wrong is lower.
Right.
So that for me was a really good signal that all our emphasis on efficiency and speed was the right one because it really accelerates people exploring different things.
Yeah.
Which is very cool.
Yeah. Iteration key to experimentation.
Yeah. Yeah.
So for Kaggle's community, people participating in competitions, people who we're working with to bring competitions to the platform, for people developing benchmarks, for the entire AI community, if they want to spend their time on innovation and discovering what works in AI beyond scaling, how should they be investing their time?
So I think so much innovation is moving to this post-training alignment and also test time exploration. The good news is that is a much better rate of return for compute, meaning you get way better bang for your buck for the amount of compute that you apply, which opens up the door to, hey, the best idea matters again, which is actually very exciting in my opinion. Honestly, one thing I'm curious about in this conversation, I mean, you have the biggest view into all the benchmarks and all the competitions.
One of the things that's exciting me the most right now is the evolution of benchmarks towards real world tasks. And the benchmarks that are really exciting me right now are ones from companies, not research labs. So take, for instance, Zapier has published a benchmark, automation bench, and the task really resembles the task that they are actually solving for their real business use cases, that they're building applications on top of frontier models, and these are the literal tasks that they're asking these models to solve in their product for their customers. And so this evolution of benchmarks from these kind of more academic or very broad, coarse-grained tasks to ones that are like literal, real-world problems, I think is something that I find personally very exciting to see in terms of trends.
100%. I totally agree. It's like less ivory tower. It's more like, does this work and have an impact in the real world?
Yeah, and that's something that has I think been part of what Kaggle competitions have had at their core since 15 years ago. Kaggle was founded on this premise of opening up the real world tasks that, at the time we needed data science talent to solve, and, bringing the data to the community and seeing how you could solve it. And now I think we're seeing the same thing with benchmarks, which is very, very cool. And I think will mean really interesting things in terms of how frontier labs choose to hill climb. So Adaption Labs is hiring globally, and you've spent your career on opening up access to AI research and opportunity globally. What is your talent thesis?
Oh, I just think selfishly, if you limit yourself to one country, you limit the pool of like talented people you can hire. So I think people who live in SF fundamentally don't understand this. Like they think SF is like just the world. And the reality is there's two things. One is if you hire globally, you find the top percentile of people wherever they are. And also it means that you're giving someone an opportunity that they wouldn't have otherwise. And so that means you find some of the most candidly sheer, determined, pure, like innovative, but also super disciplined researchers who are like, hey, this is my shot and I'm going to really make the most of it. And so I did it at Cohere Labs, and when I was at DeepMind, was starting the Google Crowd engineering office, and I see the same here. I think that you basically unlock a huge amount when you take into account a larger talent pool.
Yeah.
Yeah, but it is contrarian. I think most people are very much like SF or bust.
Yes. So I'd love to end with a fun question, which is, what is the most underrated idea in AI machine learning today?
I think honestly the most underrated idea, which I feel, is that the purview of computer scientists is going to increasingly involve interfaces. And that was previously seen as HCI, it's like a different subfield. But now our models are interacting with the real world. You have to care about how they interact. And so I think the purview of what you care about has to change. And people who take that seriously are going to do super interesting things. And I also think the other thing is that efficiency matters for how a model interacts, because it has to explore very fast. And the faster it can explore, the more it can learn about the world. And I also don't think people quite fundamentally get that, why it's so important.
Thank you so much, Sara, for joining for this Kaggle conversation. And thank you, everyone, for watching. We'll see you at the next one.